Game server hosting.
The purpose of this course is to establish fundamental knowledge about game server hosting in the cloud. There are many services and options available for hosting game servers. By the end of this course, you'll be able to differentiate between them based on your game's technology and business requirements. You'll have a good sense of what the benefits are of selecting one game server hosting solution, the limitations of that solution, and alternatives. This course cannot cover every possible business and technical circumstance, and sometimes the choice of game server hosting solution depends on a detailed analysis. Therefore, you may not have an exact decision at the end of this course for your particular project, but you'll be well informed about the alternatives and be prepared for conversations with experts. In other words, if you've not selected a game server hosting solution by the end of this course, you'll know what questions to ask to make the decisions, and you'll know what next steps to take.
Many terms have been reused in game development to refer to completely different things. Defining terms avoids confusion. The player's game software is built using a game engine like Unity, Unreal, or Lumberyard. This software runs on the player's game device. That might be a game console, a computer, a phone or tablet, a TV set-top box, or in a web browser. The game service is in the cloud. The game service provides features that either cannot be performed by the player's game software or are performed better in the cloud. The minimal function that a game service performs is sharing information between players. The game service acts like a packet relay system, passing messages. The game service is composed of several parts. The focus of this course is the game server and game server hosting. The game server is software that communicates and provides services to the player's game software during gameplay. This code is often written in C# or C++ and may contain elements from a game engine. The game server software runs on an EC2 instance on AWS. The system that provisions this instance and manages the loading and running of the game server is called the hosting service. Many applications, such as web apps, use a scalable stateless front end with a load balancer and push state information to the back end in a database. This design won't work for most games because the game is stateful and played in real time. The subject of the rest of this course are the alternatives available on AWS for hosting game server software. There are other parts in the game service. They're important to understanding the role of the game server. One part of the game service is the process of setting up a game. This is often handled by a stateless RESTful service such as a web server, a Lambda, or a containerized microservice. This code runs separately from the game server. The player's game software sends a request to the game backend, which handles authentication, authorization, retrieving player characteristics and statistics, matchmaking, and generally preparing for gameplay. The game backend identifies an available game server by making a request to the hosting service, and the hosting service responds with connection information for a game server. Game setup passes this information back to the player's game software. The player's game software connects directly with the game server. The job of game setup is done. The game backend steps out of the way and is no longer involved in the game session. During gameplay and for the duration of the session, the player's game software communicates directly with the game server. Several protocols are commonly used, and sometimes the game will use a TCP session for reliable communication and a UDP session when packet loss does not require retransmission because late packets are useless. The game server could operate independently, but in many games relies on additional services provided by other parts of the game service. These features are called core game services or just core services. Any part of the game, including the player's game software and the game backend, may be a client of core game services, depending on the design of the game service. In the most common case, the game server is the main client of core game services, and the player's game software is a client of the game server. This separation of the player's game software from core game services increases security. Core game services store persistent data, perform authentication, collect events from which analytics metrics are calculated, and perform messaging services. A combination of these things is used in most game features like leaderboards, friends list, player data, achievements, and so on. The most common core game service is a database. This is where you store game data and player data that persists beyond a single game session. Databases can be unmanaged, such as a database server running on an instance, or managed, as with Amazon DynamoDB or Amazon Aurora. Game servers are not persistent, therefore unsuitable for storing player data, which must be kept between sessions. For this reason, the game server reads the player data at the beginning of the game, uses and modifies it during the game, and stores the final player data by the end of each game. There are many other functions that core game services provide: authentication and authorization, text and voice messaging, delivery of updates, patches, collection of analytic events, and various operations and functions like customer service tools. This is in addition to what people normally consider online services like friends list, challenges, invites, and achievements. That's enough about core game services. The focus of this course is on game server hosting. The minimum work that a game server hosting service performs is provisioning compute resources on which to host game servers. This is called infrastructure management. But AWS game server hosting solutions go far beyond that. Session management involves staying connected to the game server and reporting information like the available slots in a multiplayer game. Also, recognizing when a game session has ended or when a new game session is started and whether it's currently ready to receive players or not. Game session placement involves finding an available game server to host a game that's within latency tolerances and located near players. That means choosing where to host a game globally. And it also involves shifting placement to different regions as availability of instances and location of player demand changes. Some game hosting services provide matchmaking, where multiple players can request to play a game together on the same game server. Each layer of the hosting service connects to and uses the layer below it. So matchmaking uses game session placement, which in turn uses session management, which uses infrastructure management. The way that infrastructure is managed and sessions are managed are key differentiators between the AWS game server hosting alternatives. For example, Amazon GameLift offers matchmaking features integral with game server hosting. Most other game hosting services do not. So if you wanted matchmaking in your game, you'd need to write all of it yourself and integrate it with game session placement. Most application categories exhibit a lot of similarities, making it easier to define a single application hosting solution. Games vary significantly from one game to another. This means that a wide array of hosting solutions are needed and that they're suited to different circumstances. The key characteristics that influence game design and therefore game server hosting solutions are shown. One factor is whether a game is single player or multiplayer. Another factor is whether a game is time sensitive, characterized as fast-paced or twitchy games where the player's actions happen in real time and consistent low-latency responses are essential to the game, or whether a game is time-insensitive, for example, a turn-based or casual game. Another factor is whether the player session carries through to the game design, so that the game server runs in session-based periods, or if the game server is persistent, as in a persistent world game, where the player sessions come and go, but the game environment stays active at all times. These factors lead to extreme differences in game server hosting requirements. The goal of managed game tech solutions is to make creating game servers and game services easier by working at a higher abstraction. In other words, the goal of game tech is to enable you to focus on developing your game and reduce the need to focus on managing compute instances. And the variety of game tech solutions is intended to offer a variety of entry points so that you can get the balance of automation and control that your game project requires. With AWS game server hosting solutions, for example, the alternatives have different blends of automation and control. You choose the balance based on the requirements of your game and the kinds of features you want to be provided by the hosting solution. Now you have a high-level overview of how games work in the cloud. The rest of the course focuses on the details of game server hosting.